discussion with CSS measurement units, and we'll see what are the different units in which the dimensions of the HTML elements are calculated. And there are quite a lot of few measurement units present in the CSS, but in this particular video, we will only be discussing the most commonly used ones. So let us start learning with iDigital Preneur. Now, the first measurement unit is called pixels, and you might have already seen that I was using pixels for measurements in some of the previous CSS videos. So pixels are basically an absolute measurement that essentially means that the value of the pixels does not change with the change of the screen size. So no matter if you are viewing your website on a tablet or a laptop or maybe a mobile phone, the value of pixels is always going to be absolute. The second point, and this is like a topic of discussion, and again, there is a very vast discussion over what pixels are. But in a very simple definition, pixels refer to a single color dot which is present on the screens. And whenever you create any HTML element or whenever you draw out anything on your screen, it is calculated in terms of pixels. And there are essentially millions and millions of pixels, which enables your computer to draw out different graphics and images on your screen. So pixels is that measurement value. And like I already mentioned, that pixels does not change with screen size. So no matter what screen size you are viewing your website on, the value of pixels is not going to change. The second and perhaps one of the most common CSS measurement units is percentages. Now, percentage is basically a relative measurement that essentially means that it refers to the size of the element relative to the parent element. Now, what this means is, first of all, you need to have a context that every other CSS measurement units that you define in your CSS file, which is not a pixel, that at the end of the day gets converted to pixel values, but that is done by the browser and that is not your job as a web developer to kind of calculate it. So whenever you're defining any element or any CSS measurements in terms of percentages, that essentially means that it takes the percentage value of the parent element. For example, let us say that you have a parent element whose width is 300 pixels, and inside of the div you have defined maybe a button which is, I say, 50% of my parent element. Now 50% of 300 pixels transforms to 150 pixels. Now this is essentially how the percentage calculation is done in CSS, and this in turn means that once the screen size changes, so that percentage value will also change. We'll see one of the examples what we mean by it, but just to understand that percentages are a really good way to calculate something which is responsive in nature. That means it changes depending on the screen size. Now, one of the most trickiest form of CSS measurement unit is something called EMS. Now, EMS is again a relative measurement, and it refers to the relative size of the element with respect to the absolute size of the parent element. That essentially means that if you have defined something or a absolute pixel size of a parent element, EMS are calculated on the basis of it. Now we'll see practically what EMS are all about, but EMS also helps us create a responsive and a fluid typography across our web page. And whenever we are defining anything in EMS, it makes sure that it takes the absolute reference value from the parent in which that particular HTML element is defined. And again, this also changes with screen size owing to the fact that it is a relative measurement, and it has a cascading effect. Now we'll also see what cascading effects are, but essentially in a very naive definition, cascading effect of M simply means that if a parent has an absolute pixel value and then there is a child and then there is another child inside of that child, now because the parent element has a particular absolute value and then the child has something in m's value, the grandchild is going to have like the double of what the parent has defined. Don't worry if you did not get all of that. We'll see that in practical actions. But M's are basically sizes with respect to the parent element. There is yet another unit of measurement called rems, and this is in kind of the same of what ems are, but the only difference is that the size of the element is with respect to the absolute size of the root element. Now, as we know that the root element is the HTML body tag, that's the first starting HTML tag of any HTML page that we create. So whatever size you have defined in the HTML body tag, that font size or that size is going to be taken across all of the other elements that are present in the page. And the only difference between ems and rems are that the absolute size is the parent element in terms of ems, and it is the root element in terms of rems. And it has a similar effect. It also changes with screen size, and it also has a cascading effect. Now, finally, we have VH and VW, which essentially transforms to viewport height and viewport width. And it is again a relative measurement, and it refers to the viewing height of the device screen. So whatever the height of the device which you are viewing your website on, the height and the width of the browser of the screen that you are viewing, that is what is calculated in terms of VH and VW. And this also changes with device size. Once you move to a smaller screen size, the viewport width will decrease. Once you're increasing the device height, it or device width, it increases accordingly. Now we'll see all of these CSS unit values in action. So I have my index.html, I have linked up my style.css here, and I have a blank HTML page here. And just to visualize what we are seeing so far, I will open up the dev tools. So you can open up dev tools by right clicking any place on the page and going on inspect. And once you open this, click on this tab and mobile icon that you see, which will essentially put your web page in media query or a device responsive mode. And here you can decrease and increase the size and the width and the height of your screen to kind of see the effect that you have once you start using multiple CSS units. So first of all, we'll see what we mean by pixels. Now, let's say I define a H1 and it says, and I will be using a pixel value here. So inside of my CSS, I will use the H1 tag to target my H1, and I will say that the font size is 30 pixels. Now pixels is defined by px. So you define the value and then px, hit on save. And now if I go ahead and inspect it, so you can inspect your element by clicking on this arrow icon and hovering over the element. Once you click on it, you can see that the font size of 30 pixels has been applied. And no matter what I do with the screen size, so I am decreasing the screen size, but it will always be 30 pixels, which is evident here that this H1 has a value of 30 pixels. It does not change with the change in the screen size. It is always going to be 30 pixels. And this is the most naive way and the most native way of adding any measurement units. Usually, if you are creating a responsive page in which you want your web page to respond differently based on your screen sizes, it is advisable that you don't use pixel values. But pixel values has its own advantage because it gives you a consistent font size or a consistent measurement across different screen sizes. Now let's move on to percentages and see what percentages are all about. So for this purpose, I will create a div and I will move this H1 inside of my div. And for this div, I will write out my CSS. So let's say for this div, the width is going to be 300 or let's say 500 pixels. And the H1, I will say that the font size, now it can be any CSS property, but I'm considering font size here. So font size, I want it to be 50%. Now 50% of whatever the parent size is, or to make it consistent, let us just make this as width. of 50%. Now 50% of the parent element, that is what the percentage value is. So div has a absolute value of 500 pixels. Now 50% of 500 pixels is essentially 250 pixels. So it is always going to be 250 pixels. Now if I go back and let me just calculate this, right? So right now you can see that the width of my div, if I go here, it is 500 pixels, 500 pixels, and the H1 is essentially 250 pixels, which is 50% of 500 pixels. Now, to see how this percentage value changes, what I will do is I will give this value a width of 100%. So 100% essentially means that it should take up the entire screen width, and that is the kind of the default behavior of div as well. So you can remove this as well, but essentially let's just make it like, let's just keep it here so that we know what we are dealing with. Now, once I start decreasing it, you can see that the value of H1, take a look at here, that the value of H1 starts decreasing. So as I'm decreasing the value of the screen, the width is 50% of the total width of the div. And because the essentially the width of the div is also decreasing, that is also decreasing the width of the H1 as well. So all of this is relative to the total width of my div. And just to visualize it, you can see that my div, if I go here and take a look at the width right here, so once I am increasing the screen size, the width is 100% of the viewport. So it is 1337 pixels right now. And or let's just make it a little bit more consistent, 1300 pixels, close to 1300 pixels. And if I go on H1, it should be ideally 50% of 1300 pixels. So that will be essentially 650 pixels, which is what we are getting here. And as and when I'm changing the screen size, the width is decreasing and increasing based on the device screen size. This is all about percentage value, and it is really helpful if you are creating something of a responsive design, that based on the different screen sizes, you will have multiple width and height and all of these measurements to your HTML elements. Now that we have discussed about percentages, let's now discuss about ems. So inside of my div, I will go ahead and I will say that the font size, I want this to be 40 pixels, right? And the H1 here, I will say that the font size needs to be 2 ems, and ems is defined by em. So if I go here, now take a look at what happens. So my font size is now essentially 80 pixels, and the font size of my div is 40 pixels. Now see what is happening here. I have defined an absolute font size for my div, which is 40 pixels, and I'm saying that the H1, which is essentially a child of my div, I want its font size to be two times of whatever the size of my parent is. So the font size of my parent is 40 pixels. So this will kind of transform to 40 pixels, and this in turn gets converted to 80 pixels. This is how ems calculate each other. So I can make this any value I want. I can make this maybe 1.5 m, and 1.5 m essentially transforms this H1, if I calculate here, H1 to be 60 pixels. So you can make the calculation that 1.5 into 40 essentially means 60 pixels. So you can see all of the values, whether you are using percentages, whether you're using ems, or whether you will be using rems or viewport width or viewport height. All of these measurements at the end of the day gets converted to pixels. It's just that when you're using pixel values, you are in complete control over the size of your element. But when you're using relative font sizes like these one, you are basically delegating that task to the browser, and the browser is making the decisions to change the size and everything. So this was all about EMS. Now let us also see some cascading effect and try to figure out what is happening. So my div has a font size of 50 pixels. Now here I will create a section, and inside of my section I will move the H1, and I want my section to have a font size of maybe 2 ems. And now my font size for H1, I want it to be 2 ems as well. So now let's go back and see. Now you can see that H1 is actually quite bigger. Now this is what cascading effect is. Now let us see what is happening here. So my parent was the or the grandfather or the grandparent of H1 is div, and I have defined a font size of 40 pixels in it. Now inside of my div I have a section, and I'm saying that the font size of section needs to be 2 ems. So this essentially gets converted to 2 into 40, which is 80 pixels. 80 pixels in essence. That is what 2 ems are. And now H1 is inside of my section. So now H1 will say that this needs to be 2 ems. So 2 em, and because 1 em here transforms to 80 pixels, so this essentially gets converted to 160 pixels, and that is what the font size of my H1 is. You can see it right here that the font size has become 160 pixels. So essentially you can say that this is 2 times of ems. So this is essentially 4 times whatever the font size of my div was, which is 40 into 4. So this is what cascading effect is. If you have a nesting like this, each of the parent, if you have defined a value for that in ems, it will carry forward it to the child and kind of keep on increasing the size of the child element as well. So you need to be really careful whenever you're using ems as a CSS measurement in your CSS code. Now let us see about rems. So I will say that my rem, or I can say that my HTML, I want the font size to be 20 pixels, and inside of my H1 I will say that the font size needs to be 2 rems. Now I'm not saying it to be 2 ems anymore, I'm saying it to be 2 rems. And just to prove my point that this 2 rem is actually taking up the absolute size of the root element, which is the HTML, I will define a font size in my div as well, and I will say font size is maybe 40 pixels. Now, if I go back to my page and I take a look at my H1, you can see that the font size is 40 pixels, which is essentially twice of whatever the root element size is. So this is no longer being controlled by the parent element, it is being controlled by the root element. So whatever the root element absolute size is going to be, you are always going to get the font value or the font size or any value which you are specifying in your file, you will have relative to the root element, that is the HTML element. Now rems are really useful in comparison to ems because rems actually help in defining the font size. If let's say someone is having trouble seeing the page and they kind of zoom in and zoom out your page, rems will kind of make that calculation of the adjustment of the font size and make the font size of all the or the units of all the HTML elements bigger and smaller based on the zoom level. So rems is basically root of elements while ems are just the parent element. Now let us discuss about VH and VW. So inside of my div, or let's just remove the div, and there is a section here. So inside of my section, I will say that the width or the height, let's first of all talk about width. The width needs to be any value. So it could be 10 VW. VW simply means viewport width. And now I'm saying that whatever the width of my viewport is, I want the width of my section to be 10% of whatever the current viewport width is. So my current viewport width here, it is 1200 pixels. So it will be 10% of 1200 pixels. If I go here, I take a look at my section, it is 10% of 1200 pixels, which is 120 pixels. Now, the moment I keep on decreasing it, depending on the width of my device or the viewport width, what we call it, the section width is going to change accordingly. And as you can see that it is changing as per the width of my viewport. This is what VW is all about. And essentially, if you want to use viewport width, you have to be really careful, because ideally you don't want to use viewport width with anything which is not in terms of width or height. If you're using it in terms of font sizes, you need to be really careful, and you need to make that calculated decision that the font size is getting calculated based on the viewport width itself. And similarly, the height, let's just give it a height. The height will be, let's say, 90 or 50 VH, which is essentially viewport height. And just to give it a background color to see what the height is all about, I am going to give it a color of black and a text color of white. So now you can see that depending on the height of my device, the height of my section is 50% of whatever the height of my viewport device is. Now, this is in direct contrast to what percentages are. You can argue that we can use percentages here, but percentages only work with parent elements. VH and VW is going to work with every device that you have in your arsenal, and at the end of the day every device is covered with the units of VW and VH. So this kind of brings us to the end of CSS unit measurements. Just a rule of thumb that try to avoid pixel values as much as possible, and try to use more and more of ems and rems so that you have a fluid typography and a change of font sizes and everything. And always try to use VH and VW in scarcity, because based on the device width and height, you can have some drastic effects in the changes of the sizes, and you don't want that. So just to keep things consistent, only use VH and VW until unless you really have to. So we will keep on discussing more about the CSS concepts. Till then, I will see you all in the next video.